All right, Module 6, this is part 3 as we're going through, and this just brings us into the speed with which this ice crystal process is taking place. Happens incredibly rapidly. So once again, you can see cold cloud process. So this is the top parts of my cloud, which is -15 or less than -15 degrees Celsius, and the base of my cloud is still incredibly cold and below freezing. Therefore, I can expect an ice crystal process to occur, where in this cloud here, I can actually expect maybe a little bit of both, warm cloud and cold cloud process to occur within the cloud itself. Growth in cold cloud process is incredibly quick, and that has to do with that saturation vapor pressure that I was just talking about. And two other terms that the book likes to introduce you to is rimming and aggregation. These two terms are fairly new in use within the weather terminology, so depending on what document you're looking at, you're going to see accretion, which is a better term actually, being utilized, but you'll also see aggregation and rimming being the accretion process again, because it's sticking to the exterior of the material, the ice crystal nuclei material. So the ice crystal, same process again as the vapor pressure, and then just terminology as we're getting there. When it's going to begin to snow, that whole process that's taking place before the snowfall starts is something that only really got started maybe an hour to a half hour before you're seeing the actual snow or ice crystals or snowflakes come out of the clouds themselves. So snow is basically precipitation that reaches the surface without melting. And that's a key piece of what we're talking about. Snowflakes are very specific structures that come as six-sided things. So whenever you had heard that no two snowflakes are alike, and that's true if I go down to minute detail, no two snowflakes are alike, but all snowflakes are structures and sizes and shapes that can fall into what ice crystals can be made into, which is six-sided or multiples of that six structure. So I can go 6, 12, so on and so forth as I go up. They come, I believe, in 36 sizes and structures. But with that said, I have a video on snowflake formation and sort of doing a snowflake safari for fun, and that is posted in the modules, and I think I have it listed as like part 3 or part 4, but it's right there for you guys to watch, and it's made by Science Friday. And it's well done. It's kind of fun. Just talking about how they're specific structures and shapes and quite pretty. So snow profile. We had done the profile on the other page where I went through the little atmospheric profile, but this is the same profile again. See that the temperature never raises above 0 degrees or 32 degrees Fahrenheit, and therefore I can expect snow because they will stay solid all the way down. And these are different snow crystal forms, so notice six-sided structures, and even this disc-looking thing is a six-sided structure if I was to zoom in. These are called spindle top snowflakes. Spindles are pretty common in their sets. It's one of the common structures. Most of the time you get sort of like a junky six-sided messed up formation as it goes through. As far as snowfall and where can we expect annual snowfall versus annual precipitation in general, you can see common snowfall in the United States, purple being the greatest accumulation of snow in average to deep whites up here, deep whites, not these whites, meaning that there was no snowfall or under 15 inches of snowfall down below. And even here where we are in New York is the slightly darker blue here. And so we can see over the course of the entire cold season that we would get between 30 and 59 inches. And that can be melting and refreezing. Now, with that said, we are what's called coastal climate. So we don't necessarily always receive up to that 39 inches because we are so close to the ocean. We are temperately similar all year round, which means our cold is not as cold as places that are on the same latitude as us. So if I drive inland, I can expect colder winters and hotter summers, more extreme. Where the ocean, being so close to the ocean, the Atlantic over here, where we live in Valhalla, will actually keep the temperature very similar so that our hot is not as extreme in the hot and our cold is not as extreme in the cold, giving us sort of an averaging, right? So there's some fluctuation, but not as great as inland from our latitudes. Over here is just a little bit of precipitation showing us the average inches of rainfall per year, and we can see that we get some pretty good rain. And actually, when we begin to talk a little bit more about global climate change and how our climate is altering, I will talk about how the New England regions, so New York on up to Maine, are actually experiencing wetter. We're about 50% wetter than we historically were 30 years ago. So while the rest of the country will be going through drought as the climate begins to shift and alter, there's a high level of predictability that this region will be going through a wettening. So we will get wetter. Unfortunately, it's not in the seasons needed for useful summer heat. So we're not seeing wetter spring. What we're actually seeing is wetter fall going into winter months. And that looks like it's going to consist or be persistent as the climate continues to alter. We mentioned lake effect snow, and I mentioned very briefly when I talked about fog cover, I mentioned lake effect snow. But lake effect snow has to do with the fact that when I move over incredibly large bodies of water, I can pick up moisture material. And since those bodies of water have a high specific heat capacity, they're warmer than the atmosphere around them, meaning that moisture and the air just above the lake itself is warmer than, and therefore will rise. Adiabatic process, right? We're putting all the pieces from all the modules together to create one thought now. So this adiabatic process will create moisture to rise. That moisture will continue with the wind currents, right? Because we see the wind currents that are blowing it. And they will continue to rise up through the atmospheric levels, reaching their dew point, so the temperature at which water will come out of suspension. And that creates the base of the cloud, the lifting condensation level. That cloud then can formulate. It can do a ice crystal or a condensation nuclei process, increasing the droplets or ice crystals in size through processes of accretion or processes of coalescence. Once those little ice crystals or water droplets increase in mass to a point where gravity exceeds the buoyancy of that material, they will get pulled down to Earth, creating a natural region that I will find high levels of snow, known as lake effect snow. And we see that pretty common in on the other side of New York State. And you can see that in these images here, how there's high levels of snowfall in places like Buffalo and Rochester, which is not so surprising, but true, right? So as we go through. Rain is associated with warm cloud process, but once again, the cold cloud process can produce both snow and rain because the snow crystal can come out of the clouds and melt. So, it can be both. But rain is most commonly associated with warm cloud process, and warm cloud process is going to make rain. They can, however, also produce freezing rain because those rain droplets themselves can be coming out of the cloud at temperatures just above freezing. So they can literally be 1 degree Celsius, right above freezing. And therefore, when they hit something that is cold enough to be freezing, the latent heat process can take place. They can literally give up that energy to the atmosphere around them and freeze on contact. So I can still get that freezing rain even out of a warm cloud. Rain, this is the examples. I can see that when I come out of the base of the cloud, so the lifting condensation level, the LCL, the base of the cloud, I am warmer then freezing, because I can see, I see in this example, they have my base of the cloud being -4 degrees Celsius, but my atmosphere is warmer then, so I'm coming out in a form that is actually liquid, and I am